What we have here is what we want to do is we want to do batching. So we've got our click predictor. Let's take a look here real quick. We've got our click predictor, and it looks like this. It is performing better, in my opinion, with just the few samples that it's currently training on. You can see every training sample is being visualized right now. What I want to do is start batching it, because we need to get more data happening, more data. It's not, and then we need to run through more than one epoch. Hey, just a random. Am I the first? Yeah, you're here. You're the first one. Good to see ya. We're going to continue today on our click tracker. I want to do batching. I want to see if we can get some really good results. Because right now you see that little yellow dot on the screen, that little yellow dot that you see on the screen, it's kind of flowing all over the place. It's not really going where I think it should go, right? It needs to be aligned with those green dots. And the green dots are happening all over the place, but the yellow dot is just kind of wandering all on its own. So I think we're at the point where we've got a good model and we just need to train it properly. We've got to pre-collect the data, pre-aggregate the data, and then batch process it using a hardware accelerator, which right now it's currently all CPU based. It's all CPU based because you're just looking at every training sample and its adjustments over time. And we probably adjust the learning weight and some other things from there. So that's what we want to do today. And we might have, I do have to jump in a little bit. Hey, Quantified Quantum, hey there, how's it going? Good to see ya. Look out, look at what you did. See the click tracker? See that click tracker there? That was you. You're the one who got this started. And so we've actually got things are actually looking pretty good. So now it's using a convolutional neural network. It's approved over time, and I want to now start getting more data loaded into the model. How's it going there, Vibe? So the plan is we're going to start doing some batching. So I might use the data loader. I probably should use the data loader. I wanted to do it by hand because I already know how to loop through things and collect data ahead of time. And I need to pre-generate all the embeddings so that way it works out really nicely when we do the batching. Or I suppose we could do the batching. No, let's pre-process the batching first. Let's get all the things in the right batch size, and then we'll get the labels going. Of occurrence. So what we could do is we can represent a higher order of occurrence by making the pixel bigger, something like that. That's something that we can do. 885? What are you doing there, Elliot? What are you doing? Multiple game windows opened. Training data gets combined and sent to the AI. Oh, gotcha. Okay. So good news. We are essentially going to do that through batching. And so so right now you're seeing each training sample one at a time. I'm going to do some batching, and I'm going to do some big batching, and it should accelerate the model's training like light speed. It'll be light speed. It'll be like 1,000 times faster. And so that's what we're going to do now. That's the plan for today. I've got the data now running on a hardware accelerator, which is great. I'm going to do batching. We could use the PyTorch DataLoader. We could. Before we do that, let's at least get the data into the shape that I want it to be in to be prepared for a batching scenario. Although, if we do that, we do need to update this line right here. So this line right here. Let's see, is it gonna let me? Okay, here we go. This line right here. So this will be the number of batches, essentially. We need to update that so that way the encoder won't automatically create a batch of one. That's what we have to do. Oh yeah, I realized the bug I thought I found wasn't a big deal. I just got confused since TensorFlow and PyTorch do it the opposite way. Yeah, they're different. They make some differences there. And I thought, I didn't know either. We're learning together here. Neva, we're learning together. Whoa, Neva, cool work. Yeah, Neva's done really great work here. I think this is fantastic. So this is the batch. We do need to update this line right here. So that way, once we get it into the right shape. So what we could do is the encoder, we can assume that the forward pass is always going to give us a batch of data. So we have to make some updates for that. And that's what we should always do. That's normal, standard, expected behavior. Like TensorFlow does XYC, like the pixel position and the color, the channels on the color. PyTorch does it color XY. Oh, does it? I did my CNN work in TensorFlow before. After that, a bunch of PyTorch. So I got it mixed in your brain. All right. So then Neva, here's the question then. If that's the case, if you're telling me that's the case, then is this considered the batch here? That feels wrong. It feels like this would be the batch, right? In my mind, it feels like this would be the batch. Like we're looking at it right here on this line, right here. I feel like the first 0 counts as the batch, even though you said that. And the second 0, or the last 0, would be the color channel. I think. Tell me I'm wrong. I don't know. In forward, I'm flipping it in my permutations. Okay. What we'll have to do is we'll have to test it out. I'm pretty sure. So to do update 1WH1 and the same here. So we have to do that. Why are we batching basically and in what format? Sorry if this is a stupid question. It's a good question. We want to batch because right now the training speed obviously is very slow and the output is not converging to the right answer that I want. So as you can see, it's really fun. It's wandering all over the place. It's like it doesn't know where to go. It's fun to watch it wander. So we need to update it so that way it starts converging on the right answer. Because right now it's wandering around, and it's fun to watch it wander. I like that the magenta dot. See it wander around. I want to see the converge. I want to see it converge faster. So we'll do a batch training, probably like a batch of 64 or 128 or even 256, like really big batches. So that will allow us to go poof and have the GPU go poof, give us all the data all at once. Like poof. Today is a plan. And let's see if we can get some of the batching going. Because whether I want to get this in the right shape. So we have to update this, and then the forward is going to be expecting it to be. So let's get rid of that. So that's the features. Features, encode, self.game. Features. We need to batch it. So we're going to assume the forward is already a batch. So when we do the forward, the features is a batch already. So where is this happening at? Self.train. So I would need to maintain it. We have to do this. So let's try this. So I think we just do this, and then we do this. And that should do the trick, maybe, hopefully. I think so. And so that should do it without us having to worry. And then output will be 0, something like that. So our decoder should also assume a batch, and the encoder should also assume a batch. Which means that we need to output multiple. We have to do that. So this might to do here. Okay, let's see. Is that going to work, or is that going to cause an issue? Chords pose 1, chords pose, and chords 0. So yeah, okay. So we need to do some work here, right? Because the features input is on the forward. Oh wait, where do we do that at? Forward features output. Oh, okay. So that's just the train. So let's update that here for now. Although then that makes it not a tensor anymore. Oh, I keep forgetting about that. Okay. So where are our features defined at here? Let's see where when we put it into the forward is where we really need it to work the way we want it to. So where is that at? Forward train features. So yeah, it would be right here. So this is already not yet a tensor when we run it through the train here. Features. All right, perfect. Okay. Train. Let's get the features. All right, assuming features in the forward should be expecting this to be a batch. This should also be a batch. So let's update this. Let's update the encoder. So four chords. Well, I guess I should say features here. Features. Get and then we need to do another for loop essentially. output 0. Okay, so yes, so four chords in features. And then we need output. Output equals an array. Output, I'll just say out here. Out equals that. And then we want to say output dot append out. Like that. Let's double check. Yes, looks good. Okay. Is this? We did something here. Something here is happening. What is this? Do we always need to permute this? Also, it's going to be not that. So maybe this. What? I'm pretty sure you added this. So see if that works. Permute list object has no attribute permute. Is it? Oh, right. Okay. We need to make this. We have to make this a tensor. Tense. Okay, so what we're doing is we're outputting a list and not a tensor. Permute because I moved to color last. Got it.